Hello everybody, Earth.Otherwise here to continue our journey through game programming in C++ start to finish by Earth.Otherwise. In order to render text to the screen, which is the next thing we're going to learn how to do, we need a quick and easy way to render multiple rectangles to the screen, which will contain our letters. To do so, we're going to make a new file pair called multisprite. Here we need glue.h and vector to be included. Include gl/glue.h and include vector. Now remember to put everything inside your namespace. Otherwise for me, something different for you. Remember to do this in the .cpp file as well. Now, before the actual class, we're going to go ahead and make a struct called vertex. And this struct, short for otherwise vertex, and structs have a property, just like classes, they can have a default constructor. This one will actually have two separate default constructors. We're going to have an empty one called vertex, because later on we create a vector of vertexes filled with empty ones, and you need one like that in order to do it the way we do it, and also one that takes parameters for parameter optimization. So vertex, it takes 4 floats. So float x, float y, float u, and float v. Now our little default initialization list, which is just a way to do the thing where you do member variable is equal to like x, which is our parameter, except this does it slightly faster. And we're actually going to have 4 variables called mx, which is going to take x. We're going to have my, which is going to take y. We're going to have mu, which will take u. And mv, which will take v. Now let's create those member variables. Float mx. And we're going to set a default 0.0f there. That way, if this constructor gets called, then it will give it these default parameters. That default parameter. So let's do y, same thing. Float mu, 0.0f, and float mv is equal to 0.0f. This is just a custom way to hold our all the variables we need for a vertex in a sprite. So the next struct is our sprite. So in our sprite, it contains a GLU int called mTextureID. Let's set that to 0. It contains a float, which is mDepth 0.0f, and it contains 4 vertexes. So vertex m bottom left, vertex m bottom right, vertex, make sure you use semicolons, vertex m top left, and vertex M top right. This will also have a default constructor, I believe. No? It does have a default constructor, and it's a very long one. So, sprite So, I'm going to just go ahead and copy this, Control-C, and I'm going to paste it here, and I'm going to paste it here, and you'll see why in a second. So, I'm going to back this up, put a comma there, and remove the M and make that lowercase. So now it has gone from being a member variable to a parameter. Same here. And same for all of them. You do that, I'm going to skip ahead. So with our parameters there, we have our initialization list, which we just did one up here with vertex. So yeah, it's pretty much the exact same. Now we need a third struct called sprite batch. This will just hold the information for putting our sprites together into batches. So it has it has 3 GLU ints. We have M texture ID. This will be the texture ID for all of the textures in the batch of sprites here. L is capital in GLU int. We have a GLU int, which is mnum vertices. Set that equal to 0. That is the number of vertexes that will be in this batch of sprites. So if there's, say, 4 sprites, then there is 6 and 6 is 12, so 24 vertexes. That just counts them off. And GLU int m offset is equal to 0. So there's going to be a vector. This is how far into the vector this sprite batch is. And just like the others, it has a default constructor, which is exactly the same. You do it the exact same way as the other ones. I'm just going to skip ahead. And with that function taken care of, we now move on to our class proper. We're going to have several functions in our multi-sprite class. We're going to have void init. We're going to have void clear cache. We're going to have void add sprite. Void prepare batches, and void render batches. So essentially this will set up everything. This is used when we are going to be preparing and rendering batches all the time, and the sprites might be changing or moving. This will just clear everything out so that we can do it again really quickly. Add sprite is the only function that's going to be taking parameters. Prepare batches literally just sets everything up for rendering, and then render batch is what we call when we actually want to draw. Now we have some private variables. For private variables, we actually have a private function called compare texture, which takes 2 sprites, 2 pointers to sprites, sprite pointer A and sprite pointer B, and that returns a static boolean. This will be used later to tell if a sprite should go into a sprite batch or if we should make a new sprite batch for it. Now, we're going to need 3 different vectors. So std vector, and let's just copy that. And we're going to have a vector of sprite pointers, a vector of sprites, and a vector of sprite batches. We're going to be calling that mSprite batches. This is mSprites, and this is mSorting sprites. We're going to use this here vector of pointers as a thing that we sort. So essentially, I'll show you later when we actually do it. We create these definitions. I can do it from here. You guys may need to do it manually. But before we create the definition for add sprite, we actually don't need to create a definition for add sprite because we're going to do it right here actually. Because add sprite is a very simple function. So the add sprite literally just takes the stuff that we're going to put into sprite here. So let's just actually copy this into our add sprite. And right here, we're literally just going to go mSprites dot mPlaceBack, and then we're just going to add, let's paste that again, but instead of this, we're not going to define them, we're going to just pass them in. And there we go. Oh, didn't remove float there. And there we go. Just make sure to semicolon it. And yes, that is all our add sprite does. It literally just takes all of these things and just puts a new sprite on the stack. Super easy. So now in here, we have all of our stuff, and we need to start making it. Most of these are pretty simple. Wait a second, let me just pop back into the .h file. We missed something. gluint mvbo equal to 0, and gluint mvao is equal to 0. We need these for drawing. And in here, in our constructor, we want to just make sure VBO is 0 and MVAO is 0 as well. I know that we do it here, but if we ever change anything, or if we ever create a different constructor for multisprite, we want to, make sure everything works out. But moving on to init. In init, the first thing we're going to do is check if our MVAO is, if it is not equal to 0, we're going to go ahead and return. But before we return, we're going to throw an error, meaning we actually need to num include air handler. We actually need to include a couple of other things as well. Actually, just one other thing. We need to number include algorithm, because that lets us use the sort function that we're going to be using later. And down here in init, we want to throw error. Very simple error. And we're pretty much only going to see this in debug mode because it's going to be used for debugging purposes. You tried to call init on for a sprite batch twice, dumbass. Because we should not be calling init for this more than once. And we're going to go ahead and GL bind vertex array, just the not plural, as you'll see here, plural, here, not plural. Our MV, oh, we're binding it, not generating it. I'm fucking stupid today. So then we go ahead and we GL gen buffers. I'm going to be generating 1, and we're going to be passing in the reference to our MVBO. And then we're going to bind it. GL bind buffer. Bind buffer. VBO. This first one gives us quick and easy access to putting vertices on the screen, and this second one gives us a fast way to draw. And when we're binding this buffer, we want to make sure it is a GL array buffer. Now we want to, essentially, we want to pop into Square. Like, I'll just show you where this code comes from. We do these two things. That's binding a buffer. That's the buffer data. Here we are. When we do this, when we enable a vertex array, not that, but these. When we bind our VBO ID and our UV buffer and stuff like that, we're going to do something very similar here. But this time we're going to do it for a, I'll show you. GL enable vertex attrib array. Enable 0, which is the first one. And then GL vertex attrib pointer. Okay, so this is where things vertex attrib pointer. I think I spelt that right. GL vertex attrib pointer. There we are. Okay, so 0, that is the first one. And then the size is 2 because we are working in 2D. And they are GL underscore floats. And then they are not normalized. GL underscore false. And then the stride. Okay, so essentially, when this is looking for our vertex data, how far forward and back does it have to jump in the list of data in order to find the next vertex? So here we do size of, and then our custom vertex function. So it knows that it's going to jump forward in the vector the size of a vertex in order to get to the next point. And then our const void pointer, so we want to point, when it jumps, we want to point to the first thing inside of the vertex of where it is. So we go void star in brackets, void star, and then offset of, and then we do vertex mx, and then we do another this. So this just says inside vertex, mx is where you start, and there are two things. You get those two things, and then you jump forward this amount of space in order to get to the next one. This allows us to use our custom vertex to hold our stuff, rather than having to just define an array of numbers that it can just walk through one by one. Now we're going to do a second one, essentially the exact same thing as this. In fact, it's exactly the same, except instead of 0, this is 1. And instead of mx, this is mu. And this is also 1. Because we could actually call this anywhere before this point, and then this is just a way to open that up and add this data to it. And then we want to gl bind vertex array 0. That way we don't accidentally put more stuff in there than we wanted to. And that is init. Now we want to pop down to clear cache. So this is just going to clear out our msprites.clear and mspritebatches.clear. Plural, msprites.clear and mspritebatches.clear. This is just so that if we change a bunch of the data in both of these, because we're essentially going to be regenerating this every frame, we might not have to do that if there's like no way for the number of sprites to change. Like if they are always exactly this number of sprites on screen, like I don't know, for like a static camera and like looking at the floor and then like the floor tiles, then we wouldn't need to call this, but for like anything else we would need to call it. This is just so that we clear out the data, but we keep the size of it so that we can repopulate it. So then prepare batches. This is going to be called, if you'll remember, this is called after add sprite. So in the list of things we do, we clear the caches. No. We don't clear the caches. We add sprites. Then we clear caches in the draw loop, and we prepare batches after we've added all of our sprites. So we want to check if we have sprites. So if msprites, if msprites dot empty, then we want to go ahead and throw an error. Throw error. And we're just going to call it error and give ourselves a message. You tried to prepare sprite batches without any sprites. And that won't do anything but return. We just put that there because eventually we're going to take this out, because we don't want to be throwing a system critical error in a product that we're shipping in the event that some dumb programmer tried to do that. There might be a way to set it so that we can throw non-critical errors that will only appear in the debug, but we're not going to take the time to do that right now. So next we're going to want to sort our sprites into just so that it makes adding them to batches easier. Well, actually possible. Well, it would be possible to do it, but the checks would be stupid. It's easier to do it this way, trust me. We want to go mSorting sprites dot resize, and we want it to be the size of mSprites dot size, just so that it's the correct size. And then for so 0, we want to make the length of this the size of sprites. Goddamn. Sprites.size. So we want to point our sorting sprites I is equal to the address of M sprites I. So now our sorting sprites are pointed at our sprites. Now we want to std sort M sorting sprites dot begin M sorting sprites dot end, and this is where our compare texture comes in. So this says, hey, we want to sort them. How do you want to sort them? Well, we want to sort from this point to this point, and we want to sort based on this comparison. This will literally just order our textures into groups based on the texture ID, which is an integer. If we go back here, oh wait, we actually haven't done compare texture yet. This will actually we'll do it in a second, but yeah, it will literally just return the lower, whether or not the integer is lower, which will just allow us to sort it by texture number, which is, as you know, is generated when we make the texture. So it's a way to sort textures into groups, as simply put as possible. I really am going to have to cut out all this goddamn rambling. Std vector of vertexes called vertices. So now we're going to get a list of vertices so that we can pass that into OpenGL. There is another thing. Ben uses stable sort, but all that does is it guarantees that after they're sorted, in the groups they're sorted into, they will be in order of when you put them in there. So if it's important that sprites that have the exact same texture are drawn in the way they were put in, you can use stable sort, but quite frankly, it's not, since if they have the same sprite, they're probably never going to be overlapping. Or if they are, they're all going to be overlapping in a jungle, so it doesn't really matter if they're in the correct order. So regular sort is a tiny bit faster, and it does the same thing. Anyway, so up here, we're going to need vertices.resize, and we're going to resize this to the size of M sorting sprites dot size times 6, as we're going to have 6 vertices per sprite, which is 2 triangles. Now we need 2 integers. We need current offset is equal to 0, and int current vertex is equal to 0. These will be used for moving through our sprites. These we could have anywhere from 1 to 1,000 sprites in these batches. So first, we're going to set our first sprite, because we're going to need something to compare to in the for loop that we're about to make. So M sprite batches, we need to make the first one, dot mplaceback. Mplaceback is a faster version of pushback, and we're going to put current offset. 6 is the number of vertices, and M sorting sprites 0 dot, or rather arrow, M texture ID. So what we did in this line is we created our first batch of sprites. Currently it is just a sprite. It is just one sprite, but we need this in order to put more things into that sprite batch. Essentially, you need the first sprite batch, otherwise you can't do proper comparisons. Anyways, now we need to do vertices of the current vertex, and then we're going to put a ++ here so that after we do this line of code, current vertex increases. so that we have so that we're not just putting new vertexes on top of the same vertex over and over again. M sorting sprites 0, and then we're going to put M top left. So now I'm going to copy this, and I'm going to paste it 5 more times. 1, 2, 3, 4, 5. And now we need to make sure that we build our triangle in a way that makes sense. So bottom left, and then bottom right. And then that's our first triangle. And then our second triangle is going to be bottom right, top right, and then top left. So there, we've built our triangles, and we're going to change our current offset. We're going to add 6, because the offset is now 6 sprites further in. So, now we're going to do a for loop. We're going to call this current sprite, and we're going to set it to equal to 1 because we've already done number 0. Now, current sprite is less than M sorting sprites. Don't know why that happens. Sorting sprites dot size, I think, yeah, dot size, and then current sprite plus plus. So, in this for loop, we're essentially going to do the exact same thing as here, except we're going to do a quick little if-else statement. So if else. So we're going to make the comparison if the M sorting sprites of the current sprite. So if the sprite we're looking at right now, if their texture ID is not equal to M sorting sprites, current sprite minus 1, that is, if the texture M texture ID, so if the texture ID of the current one is not the same as the last one, that means we need to make a new batch of sprites. So we can actually just grab this and place it here. But if it is, then sprite batches dot back, the last element we put in there, we need to increase the number of vertices by 6. So essentially we're saying there are 2 more triangles associated with the current batch of sprites. Essentially, there's 1 more sprite, and we're about to add it. So I'm just going to copy this here, because we're doing the exact same thing right here, except instead of 0, we're going to replace that with current sprite. V. And there we have it. So vertexes go up in accordance with the current sprite. So that will put every sprite in our M sprites in there, and now we just need to put all of that data in our VBO. So GL bind buffer, our GL GL vertex array. No, not gtext vertex. GL array buffer. There we are. And it is our MVBO. So, bind that. Now we're drawn to it. So we're going to orphan the buffer, which just means we're going to throw away all of the old data. Don't put it like that. So we're going to throw away all the old data. 0. Wait, no. Vertices dot size. That's the amount of data we're going to throw away. And times size of vertex. Not that, this. So that's the amount of data we're going to be throwing away. And then null pointer, which is the indicator that we're going to throw it away. And then GL underscore dynamic draw, which means we're going to be drawing a changing stream of vertices. So GL buffer subdata, which is how we're going to pass in our data to the orphaned buffer. It's an array buffer. 0 is our offset. This here is the same. Don't want to copy that out again. And now we're going to pass in vertices dot data. So we pass in all of our vertex data to our VBO so that it can be drawn quickly. And now we want to... I'm just going to copy this line. Except instead of VBO, it's 0. Bind the null buffer. The last thing we're going to do here is render our batches. So we want to GL bind vertex array. So essentially when we bind our MVAO, that automatically includes our VBO. So create a for loop, for unsigned int, instead of, I, new, these things can be weird. For I less than M sprite batches. Hate when that happens. Sprite batches dot size I++. We want to GL bind texture. GL texture 2D. Texture underscore 2D. And we want to bind sprite batches I dot M texture ID. So for each sprite batch, we want to bind the texture of that sprite batch, and then we want to GL draw arrays, GL underscore triangles. We're going to draw it from M sprite batches I.M offset. That is where the number of triangles starts. and m sprite batches I dot m num vertices. M num vertices. So essentially, this means that in the VAO, go to this point in the data and draw this many vertices with that texture. So GL draw arrays. Oh wait, no, not draw arrays. We want to GL bind vertex array, and we want to bind 0. And that is... Oh wait, no, here we are. In compare texture, we want to... oh wait, I'm not gonna do that here. I completely forgot to do it back when we were in our .h file. So basically all we're going to do is return a pointer m texture ID less than b pointer m texture ID. So that's all we want to do, is we just want to return if a is less than b, which will let us compare things. Anyways, now into main, our main.cpp file. So here we are currently drawing our square called triangle, and we're going to change that to number include multisprite.h, and we're going to create a multisprite. I'll just create it down here. We'll do otherwise multisprite, call it multisprite, and we will multisprite.init, and then we're going to multisprite.addSprite. So this is where the fun comes in. We're going to actually need to include our image load.h, because we're going to use that right in here in addSprite. We're going to do otherwise load png, and we're going to load the textures / apple.png, and then we're going to give it a depth of 0.0f, and then I'm actually going to come down a thing because there's a lot. So O vertex, not O vertex, that's what I called it in the other one, vertex, otherwise vertex, and then we're going to define that vertex. So let me just copy this, C, 1 vertex, 2 vertex, 3 vertex, 4 vertex, and get rid of that one. So now we have to define our vertices. So if you'll remember, if we pop over here, it is texture ID, depth, bottom left, bottom right, top right. So our bottom left is going to be 0.0f, 0.0f, that is the center of the screen, and then 0.0f, and because in PNGs the V is opposite, 1.0f. So next is the bottom left, top left. Okay, so top left is 0.0f, 1.0f, 0.0f, and 0.0f. Now, next is the bottom right, which is 1.0f, 0.0f for the bottom, 1.0f, and then 1.0f. And then I believe it's the top right, which is 1.0f, 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 0.0f. I believe I've gotten that all correct. And now we just need to draw our, instead of triangle here, I'll just comment that out. We're going to draw our multi-sprite. So, multi-sprite dot render batches. And actually, we don't want to forget to prepare our batches. Multi-sprite dot prepare batches. There we are. That should be everything. Let's see it fail miserably. And surprisingly, against all odds, it actually worked. I am going to credit my planning skills for this success. Just amazing. Anyways, we are one step closer to putting letters on the screen. This has been Earth.Otherwise. Thank you for watching.